Hello everyone, my dear friends, how are you all? This is your tutor Ayush Jain and I welcome you all to Educata Accomplished Learning. And today we are going to start with the part 4 of the chapter named as Slide for class 10th. And in this particular video, we are going to talk about spherical mirrors and the important terms related to spherical mirrors. So guys, you all know what spherical mirrors. Suppose that there is a glass of whiskey or wine or maybe a soft drink. Okay, so this is a glass. Suppose this is a glass. Now how we are making a spherical mirror? What we are doing, we are basically polishing its inner surface. Okay, either we polish this particular surface or we polish this particular surface. It will turn out to be a spherical mirror. Okay, so suppose we look towards them one by one. Now the first thing that we are going to make is a spherical mirror with the inner surface polished. Okay, this is the first spherical mirror with inner surface polished, and the second mirror that we are getting is with the outer surface polished. Okay, we are going to get basically these two types of mirrors. Now if I just tell you that we can say this mirror as the convex mirror. Okay, means the first type of spherical mirror is basically the convex mirror and the second type of the spherical mirror is basically a concave mirror. Okay, so these two are basically what? These two are basically the types of spherical mirrors. Mirrors are basically of two types: plane mirror and spherical mirror. And the spherical mirror is again classified into two types. What? Concave mirror and convex mirror. Okay, this point is clear. Now basically what we have to learn in this particular video is basically is the important terms. Okay, we are going to look towards the important terms of this spherical mirror. So I am just selecting one of the mirrors. Okay, let it be concave in this case. Okay, let it be concave in this case. So let us make a concave mirror. This is a concave mirror. Okay, so I don't think it is correct, but yes, this is basically a concave mirror. Okay, with its outer surface. Okay, with its outer surface as polished. Now the first term that comes in front of you is the pole. What is the pole? See, this is your mirror. Okay, this is your mirror. Now if we mark the center point of the mirror, okay, this center point of the mirror, this is known as the pole. Okay, the center point of a spherical mirror, in either of the case, either may it be concave mirror or convex mirror, it can be termed as a pole. Okay, so the center point of the mirror is termed as a pole. Second term is the center of curvature. What you will do now, you basically have to do a simple construction. What type of construction? You just have to complete this circle. Okay, you just have to complete this sphere via dotted line. Dotted line is basically for imaginary line. I am making it basically for imaginary line, means you just have to visualize this line. Okay, I am just making it to explain you. The mirror is only this black part, but this red line is to explain you is to explain you this complete sphere. Okay, so now what you have to do? You have to mark the center of curvature. The center of this particular sphere or a circle that you are looking towards is basically what? It is basically the center of curvature. Okay, so the center of this particular circle is the center of curvature, or this particular sphere is the center of curvature. Okay, this point is clear to you. Now the other term, the third term, is basically radius of curvature. What is the radius of curvature? You see, this is a sphere. You all know that sphere is the radius, and the radius from the center to any of its edges, any of its surface is basically same. Means if you just measure this particular thing, if you just measure this particular thing, if you just measure this particular thing, all the things are same. Okay, all these are same, and you can name it as what? You can name it as the radius. Now the radius of curvature in this particular case, though all of them are same. Okay, I am telling that all of them are same. This is also R, this is also R, this is also R. But if we are just talking about a spherical surface and we are talking about the radius of curvature, then the radius of the curvature that we have to consider is basically the radius, the line joining the center of curvature and the principal axis. Okay, the line joining the center of curvature and the pole. Okay, This is the center of curvature and this is the pole. So the line joining the center of curvature and the pole is basically known as the radius of curvature. Now comes another term, which is the principal axis. What you have to do? It's a simple thing. See, it's a simple thing, very much simple thing. What you have to do? You have got the center of curvature, you have got the pole, you have to join these lines and just extend it. Okay, over here, over here, over everywhere. You can extend it over here also. No problem in that. Okay, you just have to extend this line, and this particular line is known as the principal axis. What is this line? This line is basically known as the principal, P-R-I-N-C-I-P-L-E. Okay, principal is basically the head. No, that is P-R-I-N-C-I-P-A-L. This is P-C-I-P-L-E, principal. Okay, principal axis. Okay, so this thing is clear to you. Now the another term, principal focus. What is this principal focus? See, you have to understand one thing in the case of principal focus. That is, I am going to explain it via diagram. See, what is this? This is a concave mirror. Okay, and what is this? This is a convex mirror. Okay, I am just polishing its outer part and inner part in this particular case. So concave and convex mirror respectively. Now what you have to do? You have to draw a principal axis from this particular line. You may make it dotted, you may not make it dotted, it's your wish. And yes, done. So this is a concave mirror, this is a convex mirror, and this is the principal axis. Now see, suppose you just light up a torch over here. Okay, suppose this is a torch and it is lighted from here. Now we learned in the Newton's corpuscular theory that light always travels in a straight line and it travels in the form of beam. Yes, we learned it. Okay, so what will happen? See, this is the beam of light. It is passing something like this. Okay, suppose this is also a beam of light. It is passing something like this. Okay, means the beam of light is basically, in this case, passing parallel to the principal axis. See, this and this are parallel. Okay, this and this are parallel. So the beam of light is passing basically parallel to the principal axis, and because they are passing parallel to the principal axis, what we can do? See, let us just look towards the construction. So when it strikes at this particular point, draw a normal. Okay, this is basically the normal. At this point also, draw a normal. Okay, this is normal, and we all know that in any of the cases, the laws of reflection say that the angle of incidence is always going to be equal to the angle of reflection. So this is the angle of incidence and this is also the angle of incidence. Now if we are just constructing the angle of reflection, then where will we get it? We will get it somewhere over here. Okay, we will get it also sorry, by mistake, we will get it somewhere over here only. Means they both the reflected rays will strike at a particular point, and this particular point, when after the ray of light passes parallel to the principal axis, strike or meet both the points where they meet, this particular point is known as what? This particular point is known as the principal focus. Okay, this is what? This is the principal focus. Principal focus. Okay, now in this particular case, what will happen? Will the diagram be similar in this case? No, it will not be similar. See, what will happen over here is something like this. Okay, suppose this is the parallel ray which is passing. This is also parallel ray which is a ray passing parallel to the principal axis. Now in this case, basically if we apply the laws of reflection, it should pass from over here, but it will just go inside. If we apply the laws of reflection, this is the normal, this should be reflected ray, but it will just pass inside. Okay, and the point, and this particular point that we are getting is the principal focus of what? Principal focus of what? Convex mirror. Okay, this is for concave mirror, and this thing is basically for convex mirror. So in both the cases, we are getting different principal focus. Okay, in concave mirror and in convex mirror, and on the other sides of a mirror. Okay, that's why sometimes in the case of concave mirror or convex mirror, we get a diminished image or an enlarged image or a virtual image or an erect image or inverted image, real image. We can get anything. That is just because of the position of the object and the type of mirror that we are using. Okay, now the other thing, focal length. What is this focal length? See, if we are just talking about the focal length, it's a simple thing. You just have to do a simple thing. You got the principal focus. You are having what? Pole. Yes, you are having the pole, you are having the focus. What you have to do? You have to just measure the distance in between the pole and the principal focus. Okay, so the distance that you get, that is present basically between the pole and the principal focus, that is known as the focal length. Okay, the distance between the pole and the focus is known as the focal length. In this case also, similar thing. Okay, distance between this point and this point, this is known as what? This is known as the focal length. Okay, so I think that focal length is also clear. Aperture. What is this aperture? If we are just talking about the aperture, aperture denotes the size of the mirror. But how can we measure size? Do we have to do pi d? Okay, pi d? No pi d. What you have to do? You have to take the end point of this mirror. Okay, this is the end point of this mirror, and also the end point of this mirror. Okay, means the endpoints of the mirror, and you have to join these endpoints. Okay, this is the line joining these endpoints, and the line joining the endpoints of the mirror, that is known as the aperture of the mirror. Okay, in both the cases. Okay, in this case also, this is the line joining both the ends of the mirror, and that's why this is known as what? This is known as the aperture of the mirror. You can also define the aperture of the mirror as the size of the mirror. Okay, so I think that all the terms are clearly understood by you. In the further lectures, we will look towards the ray diagram formation, types of images that we are going to get, and we will look towards different position where the object can be placed, and the image that we are going to get corresponding to that in both the cases, in concave mirror and convex mirror. Okay, so that's all for today. Hope you enjoyed this particular lecture, and if you did enjoy, please do press the like button. Please do subscribe to my channel. Please do press the notification bell. I don't think that I am able to provide notes via the lectures, but I will definitely provide it, and that are going to be the huge comprehensive, and everything is going to be covered in those notes. Okay, but where will you get it? You will get in the Telegram link that I have shared in the description box. Okay, so you can just check out the description box and click on the Telegram link and just join the Telegram channel. Okay, till then, see ya, take care, and bye bye.